The ocean is not a garden. It is a high-velocity theater of nightmares where evolution has spent 400 million years perfecting the art of the kill. We are conditioned to fear the giants, the serrated rows of teeth in a great white shark's maw or the bone-crushing coils of a giant squid. But hidden within the vibrant, sun-drenched crevices of the coral reef lies a creature that makes these apex predators look like primitive relics. It is a 6-inch-long Technicolor marvel known as a Mantis Shrimp. Do not be deceived by its rainbow-hued armor or its delicate, feathered appendages. This is not a curiosity of the reef. It is a biological glitch, a one-punch predator that possesses the most sophisticated visual system in the known universe and a strike so violent it literally shatters the laws of classical physics. To understand the Mantis Shrimp, you must first abandon everything you know about biological movement. Most predators rely on muscle contraction, the simple pulling of fibers. But the Mantis Shrimp is a mechanical engineer. It has evolved a complex system of biological springs, latches, and levers. Think of it as a heavy-duty, underwater crossbow. It loads its power by contracting massive muscles that compress a saddle-shaped structure on its back, storing an incredible amount of elastic potential energy. When the target is in range, the latch is released, and its clubs accelerate with the speed of a .22 caliber bullet. We aren't talking about animal fast. We are talking about an acceleration that reaches 10,000 times the force of gravity. If a human being could accelerate their arm at even a fraction of that speed, they could throw a baseball into orbit. In less than 3 milliseconds, far faster than the blink of a human eye, the Mantis Shrimp has deployed its weapon, struck its target, and retracted into a defensive stance. But the impact is only the beginning of the horror. The true terror of the Mantis Shrimp lies in the secondary effect of its strike, a phenomenon known as supercavitation. Because the strike is so unnaturally fast, the water behind the club cannot move out of the way quickly enough. This creates a pocket of extreme low pressure, a vacuum bubble. When this bubble collapses, it releases a secondary shockwave and a momentary flash of light and heat, a process called sonoluminescence. For a microsecond, the water surrounding the impact reaches temperatures nearly as hot as the surface of the sun. This means that even if the Mantis Shrimp technically misses its target, the resulting shockwave is powerful enough to stun, dismember, or kill the prey instantly. You are looking at a creature that has effectively weaponized the very chemistry of the ocean itself. This is not just a punch. It is a quantum strike. It is a collision of biology and physics that leaves no room for survival. A crab's thick calcium carbonate shell, a fortress designed to withstand the jaws of fish, is reduced to shrapnel in a single hit. A snail spiral home is pulverized into dust. Even laboratory-grade glass aquariums, designed to hold hundreds of gallons of water, have been shattered by a single, disgruntled Mantis Shrimp. It is a creature that exists in a state of perpetual readiness, a sentient weapon that views the world through eyes that can see dimensions of reality humans cannot even fathom. As the dust of the first strike settles and the shockwave dissipates, we realize that the weapon is only half of the equation. To fire a bullet in a dense, refracting medium like water and hit a moving target with 100% accuracy requires a targeting computer from the future. The Mantis Shrimp doesn't just strike, it calculates. And its sensory array is about to redefine everything you thought you knew about the limits of perception. As the light reflects off its vibrant shell, we prepare to look through the eyes of a god. If the Mantis Shrimp strike is a physical sword, then its eyes are a radar system from the distant future. In the human world, we pride ourselves on our vision, our art, and our technology, yet we are effectively colorblind compared to this crustacean gladiator. To understand the world through the eyes of a Mantis Shrimp, you must first acknowledge the limits of your own biology. Human beings possess 3 types of color-sensing cells, or photoreceptors: red, green, and blue. Every masterpiece in the Louvre, every pixel on a high-definition screen, and every vibrant sunset you have ever witnessed is merely a combination of those 3 colors. The Mantis Shrimp, however, possesses 16 distinct color receptors. It doesn't just see more color, it perceives a psychedelic reality that is physically impossible for the human brain to process. It sees deep into the ultraviolet spectrum. It detects infrared heat signatures, and it is the only known animal on Earth capable of perceiving circularly polarized light. Imagine a world where the water isn't just blue, but a shimmering, multi-layered tapestry of hidden signals, where the very light itself carries secret messages that reveal the presence of camouflaged predators or the health of potential mate. This isn't just vision, it is a superpower. But why would a 6-inch-long shrimp need the eyes of a god? The answer lies in the lethal precision of its lifestyle. When you possess a weapon that moves with the velocity of a bullet, you cannot afford a targeting error. In the dense, refracting medium of the ocean, light bends and shadows deceive. To hit a moving target with 10,000 GS of force, you need a biological targeting computer that can calculate distance and trajectory with zero margin for error. The mantis shrimp's eyes are independently mobile, mounted on stalks that scan the environment with mechanical efficiency. Each eye is divided into 3 sections, allowing for what scientists call trinocular vision. Unlike humans, who need 2 eyes to perceive depth, a mantis shrimp can achieve perfect 3D depth perception with a single eye. This allows them to track a target with one eye while the other eye scans the periphery for incoming threats. It is a decentralized intelligence system, a biological high-speed fiber optic network that processes visual data at the edge of the eye itself before the signal even reaches the tiny brain. In the competitive landscape of the coral reef, information is the only currency more valuable than power. These eyes allow the mantis shrimp to communicate through secret channels. They can reflect specific patterns of polarized light of their own bodies, signaling their territorial status to other mantis shrimps without alerting massive predators like octopuses or sharks, who are blind to this spectrum. It is a stealth fighter draped in neon, a creature that operates on a frequency that the rest of the ocean simply cannot hear. However, even the most advanced radar and the most powerful weapon are useless if the machine itself breaks under the pressure of its own strength. As we look deeper into the mantis shrimp's design, we find that its visual genius is matched only by a structural engineering miracle. To handle the recoil of its own quantum strike, it has developed an armor so resilient that it is currently being studied by the military to build the next generation of tanks and aerospace frames. We are moving from the eyes of a god to the shield of an immortal. The greatest paradox of the mantis shrimp's existence is a simple law of physics. For every action, there is an equal and opposite reaction. When you strike a target with a force of a .22 caliber bullet, generating 10,000 GS of acceleration, your own weapon should, by all logic, shatter into dust upon impact. Yet, the mantis shrimp can strike thousands of times, day after day, year after year, without a single crack appearing in its arsenal. This is a mystery of the impenetrable hull, a masterclass in structural engineering that has left human scientists and military contractors in a state of absolute awe. To solve the problem of self-destruction, the mantis shrimp has evolved material so advanced it makes modern carbon fiber look primitive. Its dactyl clubs are composed of a hyperdense, multilayered composite of hydroxyapatite, the same mineral found in our teeth, but it's the arrangement that creates the miracle. Inside the club, the fibers are organized in a helicoid structure. Imagine thousands of microscopic layers stacked on top of one another, with each layer slightly rotated compared to the one below it, creating a continuous, reinforced spiral. This spiral is a trap for kinetic energy. In a normal material, a crack travels in a straight line, splitting the structure in two. But in the mantis shrimp's club, a crack gets lost. As it tries to move through the spiral layers, it is forced to constantly change direction, losing its energy and momentum until it simply stops. It is a self-dissipating shield that manages the recoil of the quantum strike with effortless efficiency. This helicoid architecture is so revolutionary that the aerospace and defense industries are currently reverse engineering it to build the next generation of aircraft frames, high-impact helmets, and body armor for elite soldiers. But this armor isn't just an offensive tool, it is a defensive fortress. The mantis shrimp is a territorial psychopath, and at home, a carefully excavated burrow is its kingdom. When 2 mantis shrimps collide over territory, they engage in a high-speed boxing match known as ritualized combat. But they aren't aiming for the head, they are aiming for the tailsun, a reinforced tail shield that is specifically designed to absorb massive impacts. These shields can dissipate up to 60% of the energy of a direct strike, allowing these gladiators to trade blows that would liquefy the internal organs of any other crustacean. This biological resilience creates a creature that is effectively an immovable object and an unstoppable force rolled into one. However, having the world's best weapon and the world's best shield creates a very lonely life. When you are a creature built for total destruction, how do you find a way to live with others? How does a killer find a partner? As we move beyond the physical armor, we discover a side of the mantis shrimp that is even more rare in the wild, a complex, social, and even romantic intelligence that defies its monster reputation. We are moving from the machine of war to the mind of the assassin. Most crustaceans are perceived as mindless scavengers, driven by nothing more than hunger and basic instinct. But the mantis shrimp breaks every rule in the book. It is a tactical genius with a cognitive capacity that rivals vertebrates. This is not just a biological killing machine. It is a creature with a high-functioning memory and a personality that ranges from cold calculation to surprising social complexity. Scientists have discovered that mantis shrimps can recognize individual neighbors by their unique scent and visual patterns. They remember who they have fought, who they have defeated, and, more importantly, who they should avoid. This is social intelligence in its most primal, effective form, suggesting a brain far more intricate than its size would ever imply. They are effectively the lions of the reef, patrolling their borders and managing their resources with a level of precision that is terrifying to behold. A mantis shrimp's burrow is not just a hole in the sand. It is a strategic stronghold. They will spend hours perfectly arranging shell fragments and coral rocks to create a defensive perimeter. If a rival intruder enters this kill zone, the mantis shrimp doesn't just attack blindly. It performs a cost-benefit analysis. It uses its advanced 16-color vision to assess the size, strength, and health of the intruder before deciding whether to deploy its lethal clubs or use a series of warning signals to avoid a costly fight. Perhaps the most shocking revelation in the saga of the mantis shrimp is their reproductive life. While most sea creatures scatter their eggs into the current and vanish, many species of mantis shrimp are strictly monogamous. They form pair bonds that can last for over 20 years, a lifetime in the ocean. They share their burrow, coordinate their hunting efforts, and even take turns protecting and cleaning their offspring. This long-term partnership is a mechanical necessity. When you possess a weapon that can liquefy bone in a single millisecond, you cannot afford a domestic misunderstanding. They communicate their intentions through a silent, shimmering language of polarized light, performing intricate dances that only their partner can decode. But do not let the image of a family man fool you. The moment a predator threatens a sanctuary, the switch flips instantly. There is documented footage of mantis shrimps, creatures the size of a human hand, attacking octopuses 5 times their mass. They don't just strike. They aim for the soft, vital nerve centers with surgical precision, forcing the massive cephalopod into a panicked retreat. They are the only creatures in the reef that don't just survive the environment. They dominate it through a combination of psychological warfare and physical supremacy. Yet, every apex predator eventually faces a challenge that cannot be solved with a punch or a stare. As we enter the final stage of the mantis shrimp's legacy, we look beyond the reef and into the future. We are about to discover how this ancient gladiator, having survived 5 mass extinctions, is now teaching humanity how to save lives, build better technology, and understand the very fabric of the universe. We are moving from the mind of the assassin to the eternal legacy of survivor. We have deconstructed the mechanics of the one-punch kill, the godlike perception of the 18-dimensional eyes, the military-grade helicoid armor, and the cold, tactical brilliance of the assassin's mind. But to view the mantis shrimp merely as a biological curiosity is to miss the greatest lesson nature has ever taught. This 6-inch-long crustacean is not just a predator, it is a survivor of epochs. While empires have risen and crumbled, and while 99% of all species that ever lived have vanished into the fossil record, the mantis shrimp has remained essentially unchanged for over 340 million years. It has survived 5 mass extinctions, watched the dinosaurs rise and fall, and witnessed the very continents drift apart. It is a perfect organism because it found a way to bridge the gap between biology and physics. Today, as human technology pushes into the next frontier, we are finally beginning to catch up to the mantis shrimp. We are no longer just observing it, we are mimicking it. In high-tech laboratories across the globe, engineers are using the mantis shrimp's DNA blueprint to revolutionize human life. We are building cameras that mimic its 16-color vision to detect cancer cells long before they become visible to human sight. Because the mantis shrimp can see the shimmer of polarized light, which changes when tissue becomes cancerous, it is teaching us how to save lives with a single glance. The legacy of this gladiator is written in our future. We are designing aircraft frames and high-impact helmets using the helicoid spiral pattern of its clubs, creating materials that are lighter than aluminum but tougher than steel. We are building satellites that use its trinocular depth perception to navigate the dark vacuum of space. The mantis shrimp is the ultimate teacher of efficiency, a living proof that the most powerful forces in the universe do not always come in the form of massive whales or towering sharks, but in the form of a small, colorful shrimp that has mastered the art of the strike. The ocean continues to change. The waters are warming, the corals are bleaching, and the balance of power is shifting. But the mantis shrimp remains an immovable object. It continues to patrol the shifting sands, its eyes scanning the reef with 16-dimensional precision, waiting for the next challenger to enter its kill zone. It is the immortal boxer of the deep, a creature that has mastered the most difficult feat in nature, the ability to be both a beautiful work of art and a terrifying machine of war. As we close the file on the mantis shrimp, we realize that the reef is not just a place of beauty, it is a laboratory of perfection. And in that laboratory, there is only one king that demands absolute respect. He is small, he is vibrant, and he is waiting. The saga of the quantum assassin is complete, but the battle for the ocean's throne is far from over. Is the mantis shrimp truly the most technically advanced creature on Earth, or does the strategic genius of the orca or the raw, unstoppable power of the honey badger still hold the crown? The decision belongs to you. Head to the comments right now and cast your vote. Who is the ultimate king of the wild? Make sure you hit the follow button and turn on all notifications so you don't miss our next deep dive into the world's most dangerous secrets. The ocean is vast, but legends like these are few. We'll see you in the next episode.